All right, happy days. Today it's time to factor out linear expressions. This is chapter 5, lesson 8b, and your learning target is exactly that. I know how to factor linear expressions. Remember what linear expressions mean. Linear means that there is one variable to the first power. Okay? That's what that means. So that's like x to the 1. Or just x, because we don't have to put x to the 1. X squared would not be a linear expression in that way. Okay, so let's define first what factored form means. And factored form is a linear expression is in factor form when there is no greatest common factors of the terms inside the expression. Okay, so this is what we're doing today. We're going to factor out linear expressions, and so in order to do that, the first thing we need to do is we need to find the greatest common factor of each term. Okay, and a term, remember, is just whatever is just together, being multiplied or divided together. They're not broken up by an addition or subtraction sign. Okay. The second step is to combine all the common factors by circling them. Okay, that doesn't change from when we found the GCF of monomials. And the third thing is simplify the common factors and put those, the simplest form of those common factors on the outside of the parentheses and write whatever is left over, whatever we couldn't take away inside the parentheses. Okay, what you'll notice is that this is the opposite of the distributive property. This is the opposite of the distributive property. So let's do a few examples and you'll kind of see how we factor these linear expressions. All right, example 1 is to factor 12x plus 36. And remember, the first thing that we need to do is we need to find the greatest common factor of each term. Okay, and this is the first term. And this is the addition sign breaks up the two terms, and here's the second term. So our first term is 12x, second term is 36, and we need to factor these out. And so what we'll notice here is we could do the little tree branch thing like I told you, but I know that this is 3 times 4 is 12, and 2 times 2 is 4, so that's 3 times 2 times 2 times x. And I know 36 that's 9 times 4, or 3 times 3 times 2 times 2. Okay, and if we want to go back and check this, we can do 3 times 2 is 6, times 2 is 12, times x is 12x. And 3 times 3 is 9, times 2 is 18, times 2 is 36. Okay, so we've checked our work, it's right. Now we have to combine all of the common factors by circling them. So we're going to combine right here. This is common here. The 2 over here, these are common. These ones are common as well. And then that is all that's common. We're left with a 3 and an x. That's all that's left over. Okay, so when we our third thing that we need to do is simplify the common factors and put those outside of the parentheses. And I know that doesn't necessarily make exact sense right now, but it will here in a second. And 3 times 2 is 6, times 2 is 12. So we can pull out 12 from this linear expression. And we're going to put that outside of these parentheses. Okay, and number 4, it says write whatever is left over inside the parentheses. So we have x and we have 3, and remember these are broken up by an addition sign, so we have x plus 3. Okay, remember what I said, this is the opposite of the distributive property. To write something in factored form is when you have everything out. It's essentially what the distributive property takes out of to simplify. Okay, so we would, in order to solve this, we would do our rainbow rule and we'd use the distributive property to solve, but we don't need to do that because we're trying to get it into factored form. That's what we are trying to do. What I want to show you real quickly, if you notice, some of you guys might be able to see this a little bit quicker. If we do it this way. This is the same problem, but what you'll see is we have 12x plus 36. We know right away that we can divide both of these by 12. We can take out 12 from each term, and so if you wanted to, you can just take out a 12. We know 12 divided by 12 is 1, so we're left with x, and 36 divided by 12 is 3, and so we're left with just 3. Okay, that's a lot quicker than doing all these steps, but you have to be able to see it, and you have to make sure that everything that is in the inside has completely been factored out. Okay, let's do example 2. All right, example 2 says to factor 15x plus 8. Okay, so we have 15x, that's our first term, and we have 8 as our second term. And we know that 3 times 5 is 15. So we can do 3 times 5 times x. And then 8, that's 2 times 4, and 4 is 2 times 2, so that's 2 times 2 times 2. And we've got everything's, we found the greatest common factor of each term. Now we have to combine all the factors, and what we'll notice here is that none of these terms are common. We can't circle anything. So the right answer to this type of a problem is cannot be factored. Okay, essentially what we're saying here is that this is in factored form, because if we wanted to write it as the opposite in factored form, it would be 1 times 15x plus 8. And so that would be the distributive property, but there's no reason to put that 1, so it really cannot be put into factored form. And that is how we factor linear expressions. Hope you have a great time and enjoy this lesson. All right, peace.